And just like that, we're a domain admin, and we can check who am I all. And if we just zoom out, we can see here we are a T0 account and we have domain admins. We're part of T0 admins, but we're also domain admins. And if we check the host name, we are on DC1. Today we're going to talk about something that might not be as flashy, but it's quite important to understand in an organization. I'm sure everyone's heard of someone complain about how come we've got so many different accounts. We've got one account for this, another account for that. To log on to this server and that server, would it not just be easier if we had one super account and we could just log on to everything? And I'll probably fall short of complaining about this as well. But the short answer is, well, no, we can't. So today I'll show you just why this is not a good idea to have just one account, and why it's a best practice to actually have a TN model that you follow. Yeah. Now that might sound quite underwhelming, but just stick with it and I'll show some cooler things before we go into the actual patching of the one super account. Here we've got a normal client workstation, and let's assume this client or this user has clicked on a phishing link and has downloaded some malware. The malicious hacker, now has access to this machine, and let's assume they've escalated their privileges through either some unpatched programs or misconfigurations on the workstation. Whichever way, they got local administrator on the workstation. So we'll just improvise and show that. So the malicious actor has got administrative privileges, whichever way they got it. So what they can do is they could open, maybe, because we've got Microsoft Defender running on here, they could open Defender and just add an exclusion zone. So if we just pretend we've got administrator rights on here as the malicious actor. So I've already added it in here, but they can add an exclusion to maybe ctemp, so Defender won't scan ctemp. And then what they can do, and what I've done for the purpose of this demo, is they can upload a program on here like Mimikatz. Now for the purpose of this demo, this is why I downloaded, or why I chose for them to use Mimikatz, because we can demo a lot of things with it. So for those who are unfamiliar with Mimikatz, Mimikatz is a great tool for malicious actors. Or if you just want to, I don't know, test, I probably wouldn't just upload it to a machine, but it's a great tool for dumping hashes, seeing what Kerberos tickets there is. You can make golden tickets with it. There's a lot of different things you can do with Mimikatz, but what we're going to show here mainly is to dump the hashes of users that have logged into this machine. Also, I uploaded to ctemp, but a malicious actor probably won't upload it to ctemp. That is way too obvious. So now we can go to Mimikatz. So temp Mimikatz, and we can have a look. Okay, cool. We can run Mimikatz. Now the first thing we'd want to do is do a privilege debug in order to gain elevated privileges, system privileges really. So we can see here, okay, so that's all good. Now what we want to do is we want to dump the hashes or passwords, whichever, of anyone that's logged onto here. Right, we're back in. As you can see by the time down here, a significant amount of time has passed. But nevertheless, we are back in. Just don't apply LSA protection if you're planning on taking it off again. Yeah. Right, okay. So what I was trying to show before LSA protection worked too well is we can do secure LSA logon passwords. If it did that again. Okay, if we scroll up, keep scrolling. Okay, so what this does is, can I zoom in on this? Yes, I can. Okay, so we can see here administrator, the local administrator. Let's see the NTLM hash of the administrator. We can also see the user that we currently are and their hash. And then we keep scrolling, and so this is everyone that's logged onto this machine since it's been restarted. And here we can see a T0 Stark, just because I added him in the protected users group. One sec. So we scroll up, all the way up. So we can start going, so we can see here, we've got administrator of the domain and DC1, the administrator of DC1, which is a domain admin. And we've got the NTLM hash, but also it's not saving the W digest, which is plain text, because that's disabled by default on newer servers now. But on the Kerberos, which we're not going to really touch on Kerberos on this, but we can see that it's actually got the plain text password here. So not a very secure password, but still. So we've actually got the plain text password. And we can scroll down to T0 Stark, which is also on the domain. And since it's a T0, we can kind of assume that it might be a domain admin. And we've got the NTLM hash of this person as well. Now if we scroll down, we've got the local admin, which we already have as the hacker. And we've got Wilson, who we are at the moment, with his hash. And so we can scroll down. We might find some more hashes, but that's pretty good for a find. So yeah, so we found the hashes of domain admins, and that's almost like we could always just call it here. But I'll show you what we can do with the hashes in a minute. But before we do that, we'll just have a look at some other things that we can do with Mimikatz. So if we do token list, we can see all the process tokens of people that have done things, basically, and we can reuse those tokens. So here you can see T0 Stark, we can see core administrator, which are both probably high level accounts. So what we can do is we can do token elevate, and then we can put that ID in. So let's choose this one, T0 Stark. If I copy and paste that correct, cool. Well, if we do elevate, we can see here, so if I just zoom out. Oh well, okay, it's not zooming out. I had to make this smaller, the actual screen, because yeah, just for ease. Anyways, it says impersonated, and we can see here we've impersonated T0 Stark. So, and if we do token who am I, we can see it says the same thing, but it shows us that we're T0. Now, what's pretty cool with this is what we can do is we can do a DCSync. And what a DCSync is we can do a similar thing with in-packet secret dump, which is remotely. So we could use the hash actually and do that remotely, but since we're here, we might as well do it here. It basically is going to almost coerce the DC to then gain, so it'll give us all the hashes in the domain. So if we do a DC sync all, and then we'll just do CSV so it shows it a bit nicer. And here we go. We can see that we have got these are all the users in the domain. Obviously we've not got a lot, but And as you can see, they've pretty much got, all of them's got the same password, because since it's a lab and it's for ease, that's what I've done. So don't judge me. But we can see here, we can see all the hashes for all the users. We even have the KRB TGT hash, which is, if we want to make some golden tickets, this is crucial. We're not going to do that here, but that is a pretty cool, we can do that at a different time. So yeah, this is all things that we can do with Mimikatz. Now you might also ask yourself, well, if we didn't have those passwords and we only had that, and we only got the hashes, what's so special about the hashes? Like, what can we actually do with the hashes? So I'll show you. I've already saved those hashes into a file, so if we cat that, we can see all those hashes that we saw before. I'm gonna take, so if we take T0 Stark, obviously bear in mind we don't know what the password is. What we can do is we've got several options here, if I can spell. So the first option is to try and crack this hash. So this is a NTLM, just an NTLM hash, so not V2 or anything. So what we're going to use is 1000, and actually, I probably need to save this. If we just save this, we'll just call it hash original, and I'll paste that in. And now we can do, now we can do hashcat -m1000, because we've got an NTLM hash. And then we'll use the very, what's the word? I don't know the word for it. Anyways, Rocky famous. That is because I forgot to put the hash file in. Oh, what a noob. So now we just wait. It shouldn't take too long because it is a pretty easy guessable password. So as we can see here, Hashcat has cracked the hash with this hash, and then here we have the password1 original. So that's one. So that's one thing we can do with a hash, is crack it. The other thing we can do, since this is an NTLM hash and not an NTLM v2 hash, we can pass the hash. So we can use something cool called evilwinrm, and as you can see, I have used this on different things. Let's use T0, yeah, we've obviously cracked that password. So T0 Stark T100, and we want to supply the, we'll supply the DC's, so this is a DC's IP, okay. I should have probably checked that. Well, this is the DC's IP. So just assume this is the it is a DC. So now we can put the hash in. I don't know if it's still perfect. So what we've done here, we're going to use evilwinrm, which uses port 5985, which is WinRM, and then we're going to use the T0 Stark, and this is the DC's IP, and the hash. So what we're going to try and do is connect straight to the DC. So if we run that, and boom, hostname DC1, and then we can do who am I. Oh, so difficult for me to spell who am I. Who am I all, and can I make this smaller? I can't use the wheel. It's so difficult to use the wheel. Right, okay. So we're T0 Stark, and we are part of T0 admins, and we're also part of domain admins, and that's literally it. And that's why when you log in, and this is why I'm going to explain why it's a good idea to obviously have a tiered admin structure, because a T0 is logged into a workstation, a low-level workstation. The hacker has found the hash and then logged straight into the DC, and that should never happen. So for people who are still maybe confused as to what happened, if we just do change directory to the root of the DC, and then if we just touch a file, and we'll just call it test.txt. Sorry, this is not Linux. So we'll just do new item, and we'll just call it what did I call it? Just test.txt, and we'll just give it an item type file. Item. Okay. So if we go to the DC now, hostname DC1, and then we go to File Explorer and the C drive, we can see that file that we just made, test. So that just shows that I was definitely on the DC. Something else we can do is from here we can just use x3 RDP. Since we've cracked the password, we can use the password, but we can also use the hash if we so wished. So we'll do P, and then we'll do password 1, and I think it's V for this, 192.168. So we're just going to log onto the, wrong way around. We're just going to log back onto the workstation. Okay, and we say yes. And we can see here that if we're trying to log in, it's going to kick off the other user. And this is because on a Windows server you can have multiple RDP sessions, but on a Windows client you can only have one. So if a malicious actor was trying to actually, they probably wouldn't do an RDP session, but if they did, it would be obvious because they'll kick off the other person. But we're going to say no to this, and we'll go back to our client where we've got Mimikatz open. And what we're going to do is Mimikatz has got a cool function here called, it's not actually called anything cool, but what it does is pretty cool. It's going to patch the terminal services in memory so that you can have more than one RDP session. So if we do that, I think if we go out and we run this again, debug, and if we do this again, there we see, sometimes you have to log out and log back in, or just close Mimikatz and open it back, but we can see here term service has been patched. So now if we go back to our Kali, we'll try and run that again, we can see that it just logs in straight away. So this will log in, and just give it a second. So this is logged in. Let me just, screen resolution is crap. Oh my god, what is going on? Am I just tracking it? I don't think I've even, I need to, right, let's just quickly, dynamic resolution. Did I spell that right? No. What I need is not in there. Okay. Nice. Okay. So just to prove that we are in here, we open this, and I just want to do a who am I. Okay, we can see that anyways, but okay, T0. So we've got this session going as an RDP session, but what we can also do now, let's say a T0 was logged in. Let's pretend this was a server. I could do it on a server, but we'll just do it on here. Let's pretend it's a server and there's multiple RDP sessions going on. What the malicious actor can do is in this Mimikatz session, they can do TS sessions, and you can see all the sessions then. You can see your own sessions, but you can also see active sessions. And the cool thing as well is it'll show you lock, which will be, have they locked their machine, like is the window locked or not. So here it says no, but if they locked it, it would say yes, obviously. But here we see T0 stock. So even if they logged in and they couldn't dump the hashes, but the T0 had a session running, what we can now do is if we do token elevate, and then we'll do TS remote, and we add in that ID. So what's this? ID 3, session 3, and press enter, and we are still in the CL1, but we've just taken over an RDP session. And as you can see, this is the RDP session that was, if we go back to Kali, we got kicked out, but it's taken over that session. And that's pretty cool. That's very cool. So I hope that was a good demo to just show you what a malicious actor could achieve if they got administrative access onto a machine and you use the same account for all machines. We can talk about this Kerberos as well. So we only talked about the hashes, and we only talked about NTLM hashes, not NTLM v2 or anything, which can be applied in group policy as well. But we can talk about Kerberos, which is the tickets. But for the sake of this video, we'll skip that because I don't want the video to go over for hours and hours. So how do we protect, or at least prevent, this easy escalation to domain admin and the DC? So the first line of defense that I've not implemented here, because I want to highlight the GPOs and because it's more admin, is EDRs, so endpoint detection and response system, which will generally be your first line of defense. But yeah, like I said, I want to highlight GPOs, and it's more admin. So what we're going to look at is the DC and what we can do on the DC in order to hopefully protect the rest of the domain. So here we are on the DC, and if we want to just check this, we can do host name, and we can see we are on the DC. Okay, cool. Well, the first thing I think would be to change all those passwords to something a little bit better. But for the sake of this, I'm not going to do that. But yeah, change all your passwords to obviously something complex. The other thing to do is, if we come here to users, and we can see the built-in administrator, which is a member of all the elite groups, right? Something you want to do with this is this account, don't delete it, but first we're going to, if you just rename it to maybe T0 domain admin. And put that in there. So we change that to there, and then you also want to reset the password and change this to a very complex password and keep it, well, obviously keep everything somewhere safe, but keep it somewhere safe and only use this account as like a break glass emergency account. If we look on the side here, you can see that I've created all these OUs. I've named them OU before as a prefix because I was using this lab for a different demonstration as well. But it's always a good idea to have separate OUs for different things, i.e. for workstations. Have your workstations in there, don't have them in the same one as your servers, and then also break down your users into the admins, different admins as well. Because this just makes it a lot easier when you're applying group policies. Because if you don't make these, it just comes with the built-in computers and users, and you can't apply group policies to those built-in ones. So to apply them, you have to create these OUs. Just FYI. So another thing we can do off the bat is if we come here down to users, we've got this built-in group called protected users. And those protected users, they protect sensitive accounts like your T0 accounts from credential theft. And we can add here, if we do T, so we can say, oh, we want to add T0 admins, which you might only add your T0 admins or maybe your T1 admins normally. But for the purpose of this, just to show you later on when we log back into the client, I'm going to add all three. So add that, apply, okay. I'll close this and I'll go to group policy. So group policy is where the bulk of this is going to happen. I hope this is big enough. I don't know if I can. I hope this is big enough. But okay. if we drop down all of these, just to see what, so I've already made all these GPOs, so we're not going to go make them one by one, but I've just unlinked them. So if we start from the top, if we start at domain controllers, I've made one here called restrict to DC, restrict access to the DC. And if we have a look at what this entails, we can see that this group policy allows logon locally only for the T0 admins and built-in administrators. And through terminal services like RDP, only T0 admins, but T1 admins are denied for logon locally. You can add obviously other ones in here. I've just added these ones in here so they can't, not that they've got domain, well, that was a burp. Not that they've got domain admin privileges anyways. So that's restrict access to DC. So only T0s can log into the DC. Then we move on to servers. We've got allow T1 admins, local admin. So what this does is I've created a restricted group for the built-in admins, and I've added T1 admins to this. So what this does is it gives the T1 admins local admin privileges on each server. So they're not domain admins, but for those specific servers that is linked in the OU servers, that they'll be local admins. And then we've got this credential guard and LSA protection, which I won't be turning back on, which it is a good idea, and it is a good thing to do. It's only because I want to play around with it that it's not the best idea for me to do it, because I want to turn it on and off again. But here we've enabled credential guard in this one. Even though I didn't do it with UEFI lock, it's still being not great. And then also we've added the registry key for LSA protection, which is run as PPL, and it's just this registry. So it's in the local machine, and you just add this value, run as PPL, and give it 1, and that will give you LSA protection. So that one. Then we've got deny T0 admins on servers. So this is a big one. This is deny logon locally and deny logon through terminal services for T0 admins. And that's just an extra one that I made. And then we've got this is just extra one as well. Is that kind of thing? No. We're going to skip that as well. Restrict admin tools. That was just to restrict command prompt for normal users. Then we go to workstations, which that client CL1 is. And we can see here we've got allow T2 admins. So what this is the same restricted group thing that we had up here with T1 admins, but we're going to add a T2 admin, and they're going to be built-in administrator on the workstation. So they can't access servers, but they can access workstations. Then we've got this one again that I'm not going to apply. And then deny T0 and T1 admins on workstations. So if we look at that one, that's the same thing, but it's deny logon locally and through terminal services, so like RDP, for the T1 and T0 admins. So if we now go and enable all of these, apart from credential guard, we'll do that, link enable, and this one link enabled. Now what we need to do is, in PowerShell, we can do a GP update here, and we force that. I hope this is visible, because, well, yeah. So that might take a second. Again, that's done. So now if we go back to the client, and we'll log in with this guy again. It's worth noting that we could use something like AppLocker to block certain applications like Mimikatz in group policy as well. But that run as PPL is pretty good, because it's if you don't have it, then any process running as local admin or system can attach to the LSAS and extract credentials. And LSAS is like the process where the credentials are stored basically in memory. Okay, so if we go, if we just do a if we do a GP update on here as well, just to make sure. and then we do GPO results R to check if they've applied. Right, I just had to log out and log back in. But here we can see the policies that's applying, and the user ones as well. But we're not that interested in those ones. We're interested in these ones, the computer settings. So what we can do is I've opened, since we're at T0, so let's just go through it. So who am I? All. And we can see that he's part of the T2 admins, and we know that T2 admins have local admin rights on the workstations. So we can run as administrator, and now if we try and go and run Mimikatz, we'll do a privilege debug to start it off. And now if we do secure LSA and we'll do log on passwords. So if we come down here so we haven't logged in with the T0 account or T1 because they can't log in. But when we have a look at Wilson W100, because he's in the protected users group, we won't see any password or we won't see any hash either. There's no NTLM here, and that's because he's in the protected users group. Now, at the very start, we saw Mimikatz fail, and that's because LSA protection was on, and yeah. So if I put that on, we wouldn't even have been able to open Mimikatz. We could open it, but we wouldn't be able to run any of this. But yeah, so with the protected users, we can't see any hash. So on DC1, if we use remote desktop, and we'll do cr1.core.contoso.local, connect. So if we try and use T0 Stark to connect to that machine, just close that. We can see here the connection was denied because the user account's not authorized. And even though it's a T0, so it's a domain admin, it's not authorized to log into the workstation. So if we connect again, and we try and use Wilson W100, which is a T2 admin, we can see that we have a connection, and it's just RDP'd into our previous session. So close that, close this RDP session, and from DC1 we'll do that again, and we'll just show that we'll do server 1. We'll do server 1 and we'll do T0 stock T100. And try and connect to SRV1. And we get the same error for that one as well. So as you can see for that. But what we can use is we can use T1 account to do it. And there we go, SRV1 with a T1. Cool. And I mean, I can show how to that a T1 can't log into the DC as well, but we're not gonna go back and do that. I'll just quickly show. So I don't know, it depends how familiar people are with group policies, but a group policy, you create a group policy, you can either create it down here. So in group policy objects, you can see all your group policies, all your group policy objects. So you can either click here, new, and create one here, or you can go, let's say, to servers and then go create a GPO in this domain and link it here. Either one is fine. So let's say we create one here, new, and we'll just call this test. What we can then do is go to servers and link an existing GPO which is test. Okay, I'm just gonna, it needs to be link enabled for it to actually work. So I'm just gonna turn that off in case, yeah. So if we edit that, so here we've got the group policy management editor, and we've got computer configuration and user configuration. So each one has got its own things that you can configure. And then the difference between policies and preferences is a policy will apply no matter what, and a preference is it will apply, but the user can change it if they so wish. So like in user configuration, you've got preferences, so in here we've got drive maps. So you can, let's say, create a new map drive, but a user can, you know, they can take that off if they want. It doesn't have to be there. But in here is where you can set registry options as well. Registry keys. So yeah, there's too much to actually explain here, but a big one is security settings, where we've got a lot of, like, if you go to user rights assignment, this is where we'll find log on, allow log on locally and remote desktop. If we go to security options, we can find things like down here, NTLM, restrict NTLM. So you might only want, like this one, LAN manager. Maybe you want to only use, maybe you want to only send NTLM v2 responses and refuse LM and NTLM, which will stop things like passing the hash. Yeah, there's a lot of options to consider when you do this. But so you've got, so let's say we click on domain controllers, and we've got 2 GPOs here. Actually, servers will be better. We've got 5 GPOs here. You've got link order, so it depends. The higher it is, it'll take precedence. So let's take an example for, if you were to apply a password policy, for instance, if you were to link it to the domain where you'd link it most probably. So let's say I create a GPO here, call it password policy. Shouldn't really care about the spelling, but anyways, password policy. And in here I wanted to change, so if we go to security settings and account policies, yeah, password policy. So let's say I want to change the minimum password length here, right? And I want to change that to 12. Did it do it? Apply, okay. So 12 characters. Okay, we've done that. So you'd think that if this runs, the next time it'll apply the 12 characters, but it won't, because in the default domain policy, which is link enabled as well, if we have a look at that one, and this is this is the default, so it comes by default. If we have a look at that, we can see that there's 0 characters here. Actually, why is it not 7? Did I change that? Anyways, it's because, let me just check this. Okay. Anyways, because the domain for here, the password policy is a peculiar one, because if the link order makes a difference here, if the domain policy is above, that 12 will not take effect. And so if I was to do a GP update, you're probably as bored of GP update as I am by now. And if we go to Active Directory users and computers, well, we can check as well. And we can see password policy is applied. So if we go to any user, maybe here, and I say, actually one that I don't use, and I just go, I'll just change this to password 1. Okay, and we can see the password has been changed. So there's no, and that was obviously not 12 characters. Yeah, it wasn't 12 characters. And that's because the link order matters. So here, what we want to do is you change the link order, so you put password policy above. And now, if we do GP update false, God, hopefully this is the last one. And I change the password now to password 1. It should give me an error. So the password does not meet the password policy. So that's just a quick way of showing you how the link order matters. So even though you've got policies within a domain or within a specific OU or link wherever, sometimes you need to look at the link order. And then there's something called like enforced. There's also block inheritance. But anyways, those two are more related to the order in which group policies apply, because group policies apply in a certain order. So local policies first, and they get overwritten by site policies, and they get overwritten by the domain policies. And then if you've got policies linked to specific OUs and then child OUs, they override all of them again. So if you put it's enforced, well, okay. If you put that it's enforced, then it won't get overwritten, that GPO. And there we have it, a basic tiered administration model. And yeah, I hope that was a good enough demo of how to incorporate it. So the key points is just use your tiered model. So use tier 0, T1s, T2 accounts. And you've got your users as well, but don't mix and match. Have a clear line as to T0s can only log on to DCs, because it's so easy to harvest credentials if someone's been logging into a low privileged server. So yeah, I think that's pretty much that. Thank you for listening, and I mean, I really enjoy doing this, so I hope you get something out of it as well. Yeah, awesome.